of you who are taking AP Calculus test, this section actually is not covered under the AP Calculus test. It is considered a little too complicated. Okay, but it will be definitely on your AP Calc final test. Okay, I'm going to cover it. If I'm going to cover it, you're going to be responsible. Okay. So here we go. So let's go ahead and do example number 5. The region bounded by the curve y is equal to root x, x-axis, and the line x equals 4 is revolved around the x-axis. So example number 5. Y is equal to root x, 4, and the x-axis, this guy here, we're going to rotate it around the x-axis. Okay. So I already told you what? When you rotate it around this axis, I'm going to cut it perpendicular to that this way, and I'm going to get wafer shapes, right? But this specifically tells you to use the cylindrical shell method, which is a method that's totally different. Okay, a cylindrical shell does exactly that. It is a cylinder, okay, with an infinitesimally thin thickness here. Okay, so kind of like a cartridge, an ammunition cartridge or a bullet cartridge, right? But except for having a cap on the bottom, both sides are going to be open. Okay, it's just the shell itself. So if you consider this, okay, and you have a bunch of these shells that are nested in each other, okay, like a Russian nesting doll, right? What are those things called? You know what these are called? Yeah, the ones, whatever those things are. So you have these cylindrical shells nested one inside of each other all the way through. Okay, and the way you're going to calculate the volume of this, so you're here, it's going to be on the side like this, right? So this is going to be like this, and it's going to be on the side. Everybody see that? The cylindrical shell itself, right? So the height here, in other words, it's going to be like this, and you're rotating this guy around, right? You're rotating this little slat-looking thing. And when you rotate it around, you end up with something that looks like this, but it's going to be on its side. So it's actually going to look like this. Does that make sense? All right, are we good there? Are we good there? Okay, so you're going to have to calculate the volume of this. The way you're going to calculate the volume of this is by slitting it across the top, and you're going to plop it open. Remember when we did the designing the cans thing? We did the same kind of thing here to find the surface area. All right, so we're doing the same thing. So we're going to slit this across, we're going to plop it open, and that's so it's going to end up looking like this, with the length here being what? Whatever this radius is, it's going to be 2 pi r, correct? But it's a circumference of that, right? And the height here being what? This is going to be this guy right here, right? Whatever that was. So if this was x, 4 minus x, right? What's the thickness of this? You have to multiply by the thickness, get the volume. It's delta y, right? Because now you're in y's, you're delta y's here. Okay, are we good? If there are any questions, let me know. Because I can't go any further if you don't understand this, you don't get this. Because this is the most important part right here. Being able to look at this as a cylinder, cut it open, plop it out, and being able to do the 2 pi r along with the 4 minus x. Again, because we're going to do dy, I need this x in what? In y, right? Are we good with that? Y, 4 minus y squared. So my volume will be 2 pi r. And what is this guy? This guy is the y, is it? This is just the y? Because this is x corresponding, this is going to be y, right? It's just y. So this is 2 pi y times 4 minus y squared dy. And y is going to go from 0 to, when x is equal to 4, y is equal to 2. Are we good? So once you set it up, the rest is easy. Pull the 2 pi out. 2 pi. Can't make up our mind here. 4y minus y cubed dy 0 to 2. 2 pi. So this becomes 2y squared. This becomes 1 over 4y to the 4th from 0 to 2. 2 pi. 2, I get 8 minus 4 with 0, and I get 0, 0, right? 8 minus 4 is 4 times 2 pi, so the answer must be 8 pi. Is that the correct answer? So it's 8 pi. Are we good? Did you get that? This is not easy. Again, this is not easy. It's kind of hard. But as you do the homework, hopefully you'll get more fluid with it. Let's do one more of these. Let's do one more of these, and we'll call it a day. Example number 6. The region bound by the curve is 4 minus x squared and y is equal to x, and y x equal to 0 is revolved around the y-axis to form a solid. Use a cylindrical shell method to find the volume of the solid. 4 minus x squared, 4, 2, and negative 2. And then y is equal to x. And this guy. So it's this guy right here. It's going to rotate around the y-axis. It's going to rotate this guy around the y-axis. And then we're going to do the cylindrical shell, which means that you're going to have like this, right? You're rotating this around. Okay. So when you rotate it around, you that slat, you're going to come up with something that looks like that. Okay. So now, and this is x. Okay. So what is the height here? The height is going to be this guy, right, minus this guy. So this guy was 4 minus x squared minus x, right? Which is good because we're dealing with delta x is dx's here, right? We're going to do it in an x, right? So we're going to do dx. Now I have to subtract this guy, which is x, right? Because the height here is x because y is equal to x. I'm going to subtract the x there. Okay, so that is my r, right? No, that's my height. I'm sorry, that's my height. Okay. So now I have to find the R here from here to here, right? Which is going to be from here to here, which is what? What's my distance from here to here? Just x, right? It's x, right? So it's 2 pi x, right? The circumference. Because the radius was x. Yes. Oh, 1, so sorry. This guy minus that, right? Right? Because it's this guy, which is this guy. Now subtracting the x. Okay. This is dx, and I go from 0 to, oops, here, dang it. So I need to figure this out. This is where these two guys meet. So it's going to be 4 minus x squared is equal to x. So I move over there, I get x squared plus x minus, oh no. Oh no. Because this, what? Does not fully align. It doesn't factor out. So this point here is going to be what? X is equal to 2a minus b plus or minus square root of b squared minus 4 times a times c. C is -4. So it's going to be -1 plus or minus square root of 17 over 2. So I'm going to go ahead and go from 0 to, this is obviously the plus 1. Everybody see that? Not the easiest one. So you're obviously going to mint this. Or the book doesn't mint it, but it just can't. Okay, so they're going to do halfway. We call this 1.562. They're going to say this is 1.562. Okay. We'll do the rest. So if we do that, we're going to pull the 2 pi out. 0 to 1.562. 4x minus x cubed minus x squared dx, because I put the x in there to distribute it out. 2 pi I do the integration. This guy is 2x squared minus 1/4 x to the 4th minus 1/3 x to the 3rd. Good luck doing this without the calculator. All right, that's not happening. So you got to put it in a calculator anyway. If you do this, you get 13.327. Okay. Example number 7, I am not going to do. Example number 7 is nothing more than example number 5. Okay, but it's not going to do it with the cylindrical shell method. It's going to do what you initially said, right? Initially, I told you when we're doing the number 5, example number 5, that the preferred method would be the washer method, right? Because that's simple, much more simpler than the cylindrical shell. So they're just proving that and doing that, and they're going to get the same answer. That's all they need. Okay, so I'm not going to go over that one. We're going to call it a day.